Hello, this is Dr. Hui Liu from San Jose, California, United States. My email is ibridgepy@gmail.com. IBridgePy is an easy-to-use Python platform to help traders to build algorithm trading robots. It can backtest and live trade with interactive brokers, Robinhood, and TD Ameritrade. You can download IBridgePy from www.ibridgepy.com. Please don't forget to subscribe to the channel because more tutorials are coming.
I'm going to talk about IBridgePy Backtester. You may have used IBridgePy Backtester before. However, from version 13.1.1, IBridgePy Backtesting becomes much easier than before. Backtesting is to use historical data to simulate live trading situations. And as comparison, forward testing is to run strategies in a live environment. Very likely, in the forward testing, paper account is used because if you use a real account, then there have some risk you need to think about. So that's the difference between backtesting and forward testing. IBridgePy platform is able to support backtesting. And IBridgePy live trading, if you use it with a paper account, then you can do a forward testing. When you're ready for live trading, you can simply switch to runme.py to do live trading. And IBridgePy recently upgraded the backtester and is much easier. In this tutorial, I'm going to demo how to run a backtester. Right now, the backtester runs in the following steps. You need to choose a strategy by file name, as usual. Then input your account code so that you can retrieve historical data from interactive brokers. And in other tutorial, I will introduce how to run backtesting using historical data from other data providers, such as TD Ameritrade, Robinhood, and in the future, we are working on an IBridgePy data center. Then, to start a backtest, you need to pick a backtest start time and end time. For example, you have a strategy and you want to start from January 1st this year until to now, so that you can have a confidence about your strategy. That's why you need to choose start time and end time. After the backtest, IBridgePy has a tool to analyze backtest result, and a chart or a plot will be drawn so that you can visually see how the strategy perform. Also, you can see the annualized Sharpe ratio. Calculate Sharpe ratio is displayed so that you can compare your strategy with others using the standardized Sharpe ratio analysis. After the demo, I will talk about the pros and the cons of the current situation, of the current backtester setup, because what I'm going to demo is the, I would call it the easiest default setup for IBridgePy. And also, we will talk about how to improve the current default mode to the code and give you a real-time demo about backtesting in IBridgePy. So first, I would like to talk about the strategy we're going to backtest. This strategy is called close price reversion. And this strategy is very simple. The basic idea of this strategy is if yesterday's price is higher than today's close price, which means there is a price drop at the end of today's trading day before market close. If there is a price drop from yesterday to today before the market close, then we assume there is a price reversion, which means tomorrow's price will go up. Then at this moment, before the market close, we place an order to long the position, which means we want to buy. And in this strategy, we want to buy 100% of the portfolio. If today's price is higher than yesterday's price, which means there's a price jump, then we think it's time to sell off our portfolio. Because yesterday there's a price jump and we got benefit, then it's time to sell. This strategy is here. There are two basic functions. One is initialize. In this function, we define shared variables in IBridgePy. So we have a variable called context.security to define security, which is the ticker is SPY, which is ETF to track SP500 index. We use SPY as a demo. And there's a IBridgePy function called schedule function. This function is in IBridgePy is to schedule other functions to run at specific time. In this example, it takes three variables. The first one is called daily function actually, and this is the function name. We define daily function name here, which means we want to run this schedule to run this function at some time. And there is a date rule and a time rule. The date rule is what day you want to run this strategy, want to run this function. The day rule is every day, which means every trading day, because weekends we don't trade. And the time rule defines when in a day you want to execute this function. And we said we want 1 minute before market close. And this is the time rule. So which means this function will be triggered 1 minute before market close every trading day, which is 3:59 p.m. Eastern Time, because the US market closed at 4 p.m. And we assume the price at this moment will be very close to the real close price. And daily function is the function where the trading decisions are really make. So first, we print out the time when this function is triggered. So we use an IBridgePy function called getDateTime. And then we request historical data. Because we only need a daily bar and we only need yesterday's price, so we request historical data of SPY, and we want daily data, we want to go back 2 days. The close price is this. Yesterday's close price is this, and today's close price, even if the market is not closed, but we assume at this moment the price is very close to close price already. If close price today greater than yesterday, we want to sell, so we use an IBridgePy function called order target percentage. Otherwise, we long this position. And this is the strategy we are going to backtest in IBridgePy. Switch to IBridgePy Backtester. The main entrance of IBridgePy Backtester is in the base project folder called test_me.py. Let's switch to this one. Actually, as a demo, I have another function called actually test_me easiest no hist ingest, and this is, you can copy this file to test_me.py and just use it, but as a demo, I copied testme.py and removed a lot of lines there to make it very simple scenario. Okay, open this one. You can see this file is pretty straightforward. There are only a few variables you need to define to run a backtesting. First, you need to define a file name, which strategy you want to backtest. And we want to test close price reversion, demo close price reversion.py. And this one is in my local file, which is called public examples. Then you need to input your IB account code. This is not your IB login ID, but if you open IB TWS, it will be the right there, the upper red corner of in your TWS. And to run this backtester, because IBridgePy will retrieve historical data from IB server, which means you need to turn on your IB TWS, get connected to their data server. Then the next line is reserved word in IBridgePy, which is called data provider name. We put a string IB, which means IBridgePy's backtester is connected to IB Interactive Brokers data center, and then we can retrieve historical data from there. However, IBridgePy is able to get connected to different data provider. For example, TD Ameritrade, Robinhood. Also, IBridgePy backtester can take data from local files, which means you can download historical data from any other data providers and save the data to your local file, and the IBridgePy backtester can ingest historical data from local file. And there's a special one called random. The random means IBridgePy will not get connected to any real data provider, but provide random data to backtest. There must be, you must come up with a question, why you want to use random data to run a backtester? It means nothing. Okay, the reason for the existence of this random data provider is sometimes when you are working on your project, very likely you don't care the backtest result, but you really care if your code is correct. So in this situation, the real historical data does not mean a lot for a trader to develop their code, because it can happen the code may have a lot of bugs and they are not related to historical data, and random data will work well to debug the code issue, not the real backtesting result. That's why we have a random data provider. Also, you see there is a data provider called IBridgePy, because we are working on a data center to provide more functionality for backtesting right now, but it's not released yet. So please subscribe to the YouTube channel, and we will release the tutorials about using IBridgePy data center to backtesting. Okay, and then the backtesting time period is defined by two variables. One is called end time, the other one is called start time, which means backtester will run your strategy from the start time you defined to the end time that you defined. Okay, as a demo, I defined the end time is I'm using a Python package called datetime, and define datetime dt.datetime.now, which means the current time. And also, because the current second may not be the 0, so I use a dt function called replace and set the second to 0. The reason for that is The default mode of IBridgePy Backtester is designed to backtest strategies minutely. So if the second is not 0, it will cause some problem in the default mode of IBridgePy. However, if you really want to test your strategy secondly, it's possible in IBridgePy. We will have tutorials later to talk about that situation. Then you need to define a start time. As a demo, I will run the test from now, go back to 50 days from the current time, so that I use the end time minus dt dot time delta days 50, which means from current time minus 50 days and give me the start time. And that's all you need to define in the easiest backtesting system right now. Let me repeat, what you need is file name, account code, end time, start time. That's pretty simple already. Okay, let's switch to task. Okay, it's not there. Let me run from there. Okay, backtesting started already. However, there are a lot of tags tell you something, and the reason for that, let me explain. If you are familiar with the previous IBridgePy backtesting system, the users are required to ingest historical data using a reserved word called hist ingestion plan, and to define what kind of historical data you need in your backtester. However, it's a little bit complicated for users, so that in this easiest no hist injection demo, I did not put any hist injection plan. The hist injection plan is to tell what kind of historical data you need in your strategy. Because you are the trader, you know what kind of historical data you need. So you are the best people to input it into Backtester. But it's a little bit complicated if you don't know what to do. So that we define this easiest no-hist injection. You don't need to do that. And IBridgePy will request historical data in real time to the data provider, which is IB at this moment, which means IBridgePy will detect what kind of data you need in your backtesting and request that historical data from IB server. So that's what I mean easiest and no hist ingestion. However, you can see back to 50 days, it takes some time. The reason for that is we request historical data every simulated day and get request historical data daily bar and go back 2 days. And every time we go back 50 days, which means we need to retrieve this daily bar for 2 days and go back to server pretty much 50 times. And it takes time. Backtester stopped and there's no any error. And it stopped. We can take a look about the error message. Not error message, but a warning message here. It says, IBridgePy has to request 1 minute bar from broker IB to continue backtesting, but it will be slow. Recommend to add hist injection plan in test me. And if we go back to see if there are any other messages, so pretty much that's the one we are provided. Okay, and the reason for that is our transaction, the transaction in this strategy happens 1 minute before the market close. you can see the function is triggered at 3:59 in the afternoon. However, IBridgePy Backtester does not know the transaction price at that moment, so that it has to request 1 minute bar from IBridgePy Interactive Brokers data center and use that price to simulate the transaction. That's why it happens. And you can see there's transactions sold. I'm pretty sure there are transactions bought, number of shares, and the transaction price. And that's the backtesting is done. And then I'm pretty sure everyone are interested, what is the result? So let's go to another file, which is called portfolio sharpratio.py. And the functions, actually, let's run it first. Okay, and let me explain what's going on there. So in this function, file, there is a function called use latest backtest balance log. It means the simulation backtesting result is saved in a folder called output, and there are two files created in the latest backtesting. One is called transaction log. This log shows the transaction happened during the backtesting. We can see from right now, go back 50 days, and these are the transactions happened. You can see bought, sold, transaction is SPY and the price. And there's another log called balance log. And this log has 4 columns: date, time, the account portfolio value, and this is the cash value. You see this one, which means we are holding some position, and the cash is like this. So, which means this column, this 1, 2, 3, the third column is the daily balance in your simulation. So that if we switch to this two, we are reading in this balance log, which is the latest backtesting balance log. And then we use Python plot to draw a chart, draw a plot to show our simulation result. And the x-axis is the date. And this chart didn't display the date because it will be too crowded. And the y-axis is the account portfolio in dollars. As a default value, the IBridgePy backtesting starts from $100,000 in account, and it goes as transaction happens. You can see it goes up. Oh, this is the number of day in your backtesting. So you can see the transaction goes like this, and it sounds a pretty promising strategy, and the return is 6% already. Oh, it's pretty good. And in this simulation, in this tool, we also print out the Sharpe ratio. And we have an introduction about the Sharpe ratio in our tutorial. So you can check it out there. And this is the demo for backtesting.
Thank you very much. For any questions, please send an email to ibridgepy@gmail.com. If you need any help on coding, please check out our well-known Run a Coder service. More tutorials are coming. Please don't forget to subscribe. IBridgePy is an easy-to-use Python platform to backtest and live trading. Thank you very much.